This bowl was made from a single board, and so was this bowl, although the board was a bit more extraordinary. I'm going to show you a simple jig, really nothing more than a piece of plywood, that will take any board, plain or extraordinary, and turn it into a plain or extraordinary bowl. All of the bowls that you see here began life as flat boards. This was just a scrap of ordinary yellow pine. This was curly cherry. This was spalted maple. And this was bark-included oak. Actually, it's more of a sieve than it is a bowl. In case you're wondering, bark inclusion is something that happens when two tree trunks grow too close together. The cambium goes all Harbor Freight on us, and sometimes it works and sometimes it doesn't. And this is what you get. These bowls were made from boards that were glued up to make geometric patterns. Cutting boards, some of them. This was glued up from strips of different wood species. Wedges of different wood species. A herringbone cutting board. And, well, what can best be described as phantasmagoria. Look it up. Despite the wide range of designs, all of these bowls were made in exactly the same way. The concept is remarkably simple. Take a board and cut it into rings on a bandsaw or scroll saw. These cuts should be angled, and all the angles exactly the same. Then stack these rings so that they form a bowl. Put the largest ring on top and the smallest on the bottom. Actually, the part on the bottom will be the disc that's left over from cutting the rings. Glue the rings and the disc together. Then turn the stack on the lathe to smooth out the glue joints. If you want, add some curves and some other details to make it more bowl-like. Now, there are some tricks, of course. You see, each ring has a major diameter on the top surface and a minor diameter on the bottom surface. The major diameter of each ring must match the minor diameter of the ring that's stacked on top of it. That way, the walls will have a consistent thickness, and there will be enough stock that you can smooth the joints and turn a shape. How do you make the diameters match? Well, you need to do some figuring. But don't worry, it's pretty simple, and it gets a whole lot simpler if you use the virtual calculator that I put together. Before you cut your first ring, you need to know 4 numbers. Make that 5. First, you need to know the stock thickness and the slope of the bowl wall. This is the angle at which you will cut the rings. You use these to figure the bowl wall thickness and the all-important ring spacing. Finally, you must take into consideration the width of the saw curve. Let's figure the numbers we need to turn a board into a bowl using my calculators. This comes with the plans for this project. The link is in the video description. It's an XLS file, so it will open with Excel and many other spreadsheet programs. To use it, you enter what numbers you know, and the calculator fills in the blanks. Usually, you already know the stock thickness and the slope that you want to cut. The first line of the calculator is set up to generate wall thickness and ring spacing from those numbers. Let's say the board is 3/4 of an inch or 19 millimeters thick, and I want the walls of the bowl to slope at 35 degrees. It tells me that my ring spacing is going to be 1.33 centimeters. That's 13.3 millimeters, and the wall thickness is 10 millimeters. That's about 17/32, close to 3/8 of an inch in English. And those are pretty thin walls. So I'm going to try a different slope. The greater the slope, the thicker the walls. 45 degrees gives me 12.8 millimeters, or about 1/2 inch for the wall thickness. The calculator tells me that my ring spacing is going to be 19 millimeters, or 3/4 of an inch. I think that'll work. By the way, this calculator works with both metric and imperial English measurements, but you have to change the English fractions to decimals using the chart provided. For you self-sufficient folks who like to do your own figuring, very quickly, Here are the formulas you need to figure wall slope, stock thickness, wall thickness, and ring spacing. K is the thickness of the saw kerf. And by the way, I also list these formulas in the project plan. If you don't feel like doing any figuring or using the calculator, here's a quick tip. At 45 degrees wall slope, the stock thickness is precisely the same as the ring spacing. So, use 45 degrees and you're good to go. Once you know your numbers, select the stock and plane it to thickness. Also, think ahead of what it's going to be like to turn this stock. In a normal turning, like this rolling pin here, the grain direction is parallel to the axis of rotation. This lets you cut the stock in two different ways. You can scrape it like this, or you can shear it. However, when you're turning a board, the grain direction is perpendicular to the axis of rotation. When you're turning, you're cutting long grain, and then end grain, and then long grain again, and then end grain again. There's absolutely no way you can shear when the angle at which you're cutting the grain changes with every microsecond. You have to scrape, and with a very light touch. However, there are two things you can do to make this work a little easier. The first is to choose hard, dense woods such as maple or oak. This bark-included oak was actually easier to turn than many of the softer woods that I used. The same problem applies when you're gluing up patterns. This stripe pattern, for instance, presents exactly the same turning problem as a solid board. And this herringbone pattern, well, this was a nightmare. The grain direction changes with every zig and zag. They're doable, but they're a trial. The harder and denser the woods in your patterns, the less often you'll lose your religion. The second thing you can do is rearrange the wood grain so that you're cutting mostly long grain. You do this by cutting wedges and then gluing these wedges together to form a multi-sided or circular shape, sort of a wood pie. The wood grain in these pie pieces must be parallel to the outer edges. Not only does this keep you cutting long grain, it also ensures that the wood will expand and contract from the center. If the wood is perpendicular to the outer edge, in other words, if it runs through the length of the wedge, the wood will expand and contract around the circumference, and eventually you'll get cracks like these. Let's make a wood pie. I'm going to use 4 species just like I did in this bowl: walnut, maple, cherry, and oak. Our stock is 13/16 of an inch, that's 21 millimeters thick, a little thicker than our target so that we have something to sand and plane. There are 16 wedges in this pie, so each wedge will take up 22.5 degrees of the circle. I've set the fence on my table saw sled to 11.25 degrees, and I'll make each wedge with 2 cuts. First, I cut the end of the board at 11.25 degrees. Then I flip it edge for edge and make another cut, and continue. Each cut will produce a 22.5 degree wedge. Next, we need to trim the wedges to exactly the same length. I've made a notch jig to position the wedges on the sled. To glue the wood pie wedges together, I've made this assembly jig that uses smaller wedges. We'll call these clamping wedges to avoid confusion with the bigger ones. These generate the necessary clamping pressure. Both the jig and the clamping wedges are thoroughly waxed so that the glue won't stick to them. Assemble the big wedges 8 at a time. It's all but impossible to glue up all 16 wedges and get them to fit just right. So begin by making 2 half-circle shapes. Because these are end grain joints, they will absorb a lot of glue. So apply glue to both adjoining surfaces, in effect doubling the amount of glue in each joint. Press the clamping wedges between the dowels and the large wedges to clamp all 8 parts together. Cover the assembly with wax paper and clamp a board atop it to hold the assembly flat while the glue cures. When the glue has cured sufficiently, remove the half circles from the jig and sand the adjoining edges true using a disc sander, belt sander, or a sheet of sandpaper adhered to a flat surface. Then glue the two assemblies together to make a full circle. For this wood pie, I'm using two large V-jigs to press the halves together. After the glue has cured for at least 24 hours, sand or plane the circle to make it 3/4 of an inch or 19 millimeters thick. If you plane it, take very light cuts. I'm removing just 1/128th of an inch. That's about 0.25 millimeters at a pass. To cut the rings accurately from this wood pie, we need to make another jig. So, start with a piece of 3/4 inch or 19 millimeter plywood and cut it about the same size as your bandsaw table. Attach a strip of wood to the back to serve as a runner that will ride in the miter gauge slot. Attach a stop to the bandsaw table near the outfeed edge. Either clamp it to the table or lock it in the miter gauge slot. Tilt the table to the angle at which you want to cut the rings, the wall slope. Place the plywood on the table with the runner in the slot. Turn on the bandsaw and feed the jig forward, cutting an angled slot until it hits the stop. Then remove it from the saw. Draw a line where the cut stops and perpendicular to the cut itself. We're going to arrange the pivots for each of the rings along this line. Let's start with the biggest ring. Now, the diameter of the stock is just a whisker over 10 inches or 25 centimeters. So the biggest possible radius is 5 inches or 12.5 centimeters. However, the pivots themselves are arranged for the minimum radius on each ring. To get that, you subtract the ring spacing from the largest possible radius. The ring spacing is 3/4 of an inch or 19 millimeters. So I get 4¼ inches or 10.8 centimeters. Measure down along the line from the cut and mark the position of the first pivot. Use dividers to find the positions of the remaining pivots. Set the space between the divider points to match the ring spacing and then mark each pivot in turn. Drill a pivot hole at each mark. These holes should not go through the jig. Drill a matching pivot hole in the bottom face of the stock. This too must not go completely through. Later on, when we finish the bowl, we'll plug this hole. Place the jig on the infeed side of the bandsaw table, back from the blade. Make a short pivot pin from steel rod stock and insert the pin in the bottom of the stock that you are about to cut. Then insert the protruding end of the pin into the first pivot hole, the hole you will use to cut the largest diameter. Rotate the stock into position and turn on the bandsaw. Advance the jig until it hits the stop, then begin to rotate the stock. Cut a complete circle, stopping where you started. Turn off the saw and carefully back out of the cut. Take the stock out of the pivot hole, remove the scrap ring you just cut, and put the pivot into the next hole, the one you made for the next smallest radius. Repeat until you've cut all the rings. As you can see, all of the rings fit neatly into one another, and when you take them apart and stack them, they form a rough bowl, just like that. This procedure is exactly the same, whether you're cutting up a wood pie like I just did, or a square board. However, when you're cutting a board, make sure that on your entry cuts, they must follow the wood grain. That way, when you close the rings, like we're about to do, you'll be gluing long grain to long grain. Use a brush to work some glue into each cut. Clamp the ring to a flat surface so the top and the bottom lines up and pinch the cut together with spring clamps. Repeat for each ring. And don't worry about realigning the inside and the outside surfaces to make them smooth. This actually stresses the ring and may break the small ones. Just pinch them together. you'll turn them smooth later on. Well, the rings are closed, but before we can glue them up, we have some decisions to make. You see, you can arrange these rings in a variety of patterns, and the question is, which one? I can arrange them so the wedges radiate out like the spokes of a wheel. Or I can give each one a half wedge turn and create a pinwheel. Or I can turn each one a full wedge and create checkers. Of course, the patterns you make depend a lot on what you start with. Here's our Phantasmagoria board all cut into rings, and I'm going to show you just two of the many possibilities. Here's one. The rings are positioned exactly like they were when they were cut from the board. And here's another. I've rotated each ring 90 degrees. Lives up to its name, doesn't it? Phantasmagoria. You can't be quite so free with rings cut from solid boards or boards glued up from strips. You have to put these back together with the grain direction exactly the same way it was before you cut the rings. Otherwise, you get problems like this. I've sanded these rings flat to get rid of any glue squeeze out on the adjoining surfaces. And now I'm going to glue them up to make a pinwheel. Restack the rings, applying glue to the adjoining surfaces. To keep the rings from shifting, rub 2 small pieces of 50 grit sandpaper together and add just a little grit to the wet glue. As you press each ring in place, make sure there is some glue squeeze out all around the circumference. Place a board on top of the stack and temporarily weigh it down with something heavy while you add clamps to squeeze the rings together. Incidentally, the assembly table you see here comes with the plans for this project. The glue has been curing for about half an hour, long enough that it has begun to set up, and I can temporarily remove the clamps and add this mounting block. This is a plywood disc that I'll attach to the base so that I can mount the stack on a lathe chuck. The mounting block has a hole dead center, the same size as the pivot hole in the bottom of the bowl. Using a pin, you can line these parts up so the mounting block will be perfectly centered on the bowl. Finally, it's time to turn this sucker. It's been a long road getting here, but as you'll see in a little while, the result is well worth the effort. Now, even though we've built this bowl up out of wedges and will be turning mostly long grain, I suggest that you scrape this bowl to its final shape. As it turns, you'll be cutting each wedge uphill for just part of its rotation, and if you attempt to shear, you could chunk it out. And since you'll be scraping, pay close attention to the position of the chisel relative to the axis of rotation. When you're turning the outside of the bowl, position your tools so they contact the wood slightly below the axis of rotation. When turning the inside, position them slightly above the axis. And scrape with a light touch. It will take some time, but it'll get you there. As you work, you'll find that your scraping tools lose their cutting edge a lot faster than shearing tools. They're under a lot more stress. So you need to touch them up as you go. I've set up the strip sander so that I can polish the edges at 75 degrees, like so, and then flatten the backs on this sharpening stone. We're almost home. When you have turned and sanded the bowl on the lathe, remove it from the mounting block with a saw. Plug the hole in the bottom of the bowl with a dowel. Then give the bowl a careful hand sanding, following the grain as best you can. And finally, apply a finish. If the bowl will be used to hold things to eat, be sure to use a food contact safe finish. And be sure to use a food safe wax as well. And there you have it, a bowl from a board. Nothing left to do now, maybe, except spin something.